Good morning, Williams, friends, fellow flyers. It's time to start the fuselage. We got the vertical and horizontal stabilizer with the elevator and the rudder completed. They're done. We got them trimmed down, so a lot lighter, a little bit lighter. They come in at a weight at. They are at. The elevator and the rudder is looks like 1.3 grams, so that's very, very light for my elevator and my rudder. And then my wing, I got the wing done. Here's both sides, and they, with the rudder and elevator, I'm now at a total weight of, looks like a total weight of 5.2. I'll show you my scales here. Just let me see if I can show you my scales. There are my scales. You can see that I'm about 5.2. Maybe I'm showing you what I'm looking at the behind us. Okay, there. Okay, so it's not actually digital numbers. It's just old school type. Oh yeah, yesterday I used my shirt tail to wipe my nose, and I thought I'd stepped off camera. So if I offended anybody by showing my belly a little bit, I apologize for that. My nose was running a little bit, so I lift up my shirt tail and wiped my nose. Sorry about that. So on the other video, I apologize for showing my tummy there a little bit, so I apologize for that. All right, it's time to move on to the fuselage. All right. Turn the camera back down to the table. Let's see. Okay, now one of the things I want to do is I want to prep for a couple things. One is I want to something that will hold the cowl on. So I'm going to extend my firewall holder tabs. See there, the little tip that holds it. This is something I'm doing ahead of time to help myself later. So I'm going to take some scrap that come out of the center here. These are just some scrap pieces that come out. We're trying to use only what comes in the box. Now we'll extend these areas here. All right. First thing I want to do is make sure I'm measuring correctly. And I'm going to extend these areas out. So use a pencil. You always want to measure twice, cut once. So there's that line. Here's this line. Okay. That way. That was a straight with the grain, so I went ahead and cut, go ahead and cut easy. And then it's got a curve, so I don't really need this curve going cross grain, so I probably will need to use multiple cuts here. This is a beginner's build off, fly off, so to some of you guys, I may be talking very elementary. This is, like I said, maybe boring as watching paint dry or grass grow. So, you on the keyboard there, you can take your arrow forward or the little arrow and back it up or move it forward to speed up or back up. A little tip there for watching videos, right and left to speed up or slow down, in case you didn't know that. Okay, now the reason I'm doing this is I want a location to hold my cowl on. So this is going to be going onto, I got to be careful here. I'm going to set the fuselages toward both sides. So if I lift them up, I'm putting the insides down. I've got a right side and a left side. You got to be very careful not to make two right sides here. So, and I want this to go on here and then stick past the cowl. Now, I've only got so much of a cheek cowl here, so it's going to be right in here, this area. So I'm going to glue this on and then cut it off. So I'm going to use some CA for this. It makes it hard. So here's some medium CA. If the tip ain't dried up, and it is. So let's see if we can unstop this with a little wire. Yep, there it went. I'm not a big fan of CA, guys. I'm not a fan of CA. I make a mess with CA. Go for trying to make sure it's all opened up. Yep. Okay. I'm going to go ahead and cut the exact size I want. I don't need a whole lot. I just want it to stay in place. So it looks like I'm going to divide this in half. Just divide it in half. It'll be sanded. And let's go ahead and make myself another one. You may have different ways, different ideas of doing what I'm trying to do, but that's good. I'm going to pause just for a second. Okay, I'm back. Had to do something there. All right, let's glue these on. Make sure I've got inside facing parts. My dog. Yeah, I'm extending these areas here. Okay. That's an inside. And then I'm going to put an inside over here. This is for later. Make sure that I have a place for my cowling. My dogs want to drink out of the commode. I don't like for them to drink out of the commode. And use a little thin CA2. I should, as adding maybe too much. You can't add too much weight to know. I guess you can, but okay. Make sure it don't stick to the table. All right, let's flip it over, and then I'm going to go opposite grain, so that I have opposite grain going one way. See, I've went opposite grain. I'm extending these little areas here. This is for later in the build. This is the method that I use to hold the cowling on. If you've watched my videos before, you know how I hold my cowl on. It's just an idea, it's a tip. You don't have to follow that idea. If you have other ideas, it works. So I use it. Using CA, I don't know exactly the proper way to use CA, but I'm just pouring it on, I guess. I'm always gluing myself with CA. It's one of those love-hate relationships. CA is a love-hate relationship. I love what I can do with it sometimes, but then I also don't like how it responds to certain things. So I'm putting in this little idea of using a stick to apply, or something to apply the accelerator or the instant set, was from Josh Finn. So thank you, Josh, for showing us how to apply instant set. It was a good idea, great idea. We want to share or give credit where credit is due for these things. Okay, I'm going to cut off this excess, making sure we've got a little tab there now. That is for later. Double the tab. I got one going one way, one going the other way. Okay. Now, when I do a fuselage, let's get out the plans. Let's turn over the plans. So we can see what we're doing here. Okay, I can see my rubber band rear motor mount. I says to use the dowel. We're not going to use that. We're going to use some kind of, that's something we're allowed to change, is what our rubber band or prop, and this area here that allows us to work with the. So what I want to do now is I want to decide where to put my rubber band. The more rubber you can put in a model, the better you are of getting the best flight time. So I want to put me a rear motor hook as far back as I can, but I want to be able to use my stooge to wind up the rubber band. So I want to make sure that I lay these down where I've got the insides facing up. So if I was to lift them straight up, then I would have them that they go together. So that makes sure anything I do to the inside of the model will be on the inside and not on the outside, so I don't have two right side models. So I'm going to get some more scrap wood here. This is the inserts that was in the fuselage, and I don't wish to put my remain where it's at. So I'm going to put it in the middle. My goal is to put it in the center of this area. So the center of the next window up. So I've got two equal parts here, one out of one side, one out of the other side. And I'm going to lay it on top of the model here, or underneath the model here. And let's get an actual measurement so we know what we're sharing. I'm going to go to the center of this area. So the center of this area, I have a little ruler, some kind of ruler here. My little ruler here is millimeters. So if I measure the center of the area in millimeters, it's like 35. So 35 would be the center. So half of 35 would be 17 and a half, correct? So I'm going to move it to the top where I can make my pencil mark into 17 and a half millimeter. There's 15, 16, 17 and a bit right there, the center. Let's go to the bottom, try to keep a straight line. There's 17 and a bit right there. Okay, that is the center here. That's the center. So then I want to glue this in the center, but I want the thickness, I want my little support here to be double. Like if I was to use this, that's a aluminum tubing, then I want it to be double the thickness of that, so that I would put it in the middle and there'd be plenty of meat on either side, plenty of wood on either side of the wood to give myself the support I need to make this work. So that was using that as the example. I can take them above it. I'm just going to press in the wood a little bit so I can leave a little mark of it. Then I'm going to press again. That way I can sort of see what I need. It's curved anyway, so that part will be cut off. So whatever I do on one side, I'm going to try to make it equal on the other side. So I'll just put these two pieces together and cut them at the same time. Now some people may want to wait till they have their model assembled before they add this part, but this works for me. So I'm just sharing my tips, but not saying do it this way. I'm just saying this is how I do it. If you're a beginner, should have two equal parts, and then I want to put it in the model. So I'm going to lay it over this here, make sure I got plenty of room. Put it right in the center of this and trace out the lines. Now when you trace out the lines, remember you want to not cut the lines. You want to leave the line so that you want to have a more of an exact fit. So don't try to cut all at once. I can't stress that enough. Cut little at a time, just a little bitty, drag across easy. The wood grain will catch and pull you. Okay, once I have it cut into place. Then I'm going to glue it into place. So, but I want to put me down some saran wrap here on my table. Just a little bit to work off of. An old piece don't stick very well, does it? Okay. Maybe I don't need the whole piece. Let's see. That's good enough. It'll lay right there. That little piece that I just trimmed out. And put it right in the middle. Using the thin CA. The thin CA hardens balsa. So I want to use that. And then I'm going to take the other half. I'm going to save that for the other side. But I'm going to take another piece. And if I can, I'm going to lay that on top of that another piece, because I'm going to now go all the way across and double the thickness. I know you may think, well, now you don't need that. One's enough. Nope. I want strength. I want to double glue that wood area so the wood will be over onto the parts that I'm wanting to make sure that I've got it glued securely. So I got one side for one. Let's see, did I have enough scrap left over from cutting it? Yes, I do. So I do have enough there to cut off. Well, that will be plenty of room. I'm sorry that the video is so far away, but I'll show you after I get it glued on. Just to make it look evenly, I'm rounding off that bottom edge. It ain't gonna hurt anything. You'll see what I mean in just a second. So we're gonna glue this down. I'm gonna use medium this time. And if I might go ahead and put a touch of thin at the corners, let it wick in. The less glue is better, I guess, but I don't like my models falling apart either. Okay. That's the outside. That is the inside that will support the rubber band. Okay. Added a lot of extra weight in the back of the model, but it has to be. Okay, let's put the other side in. I want to measure the location. It was 37 and a bit, 37 and a half actually. I mean 17 and a half, excuse me. To me, it's just easier to install this now than to try to install it later. I'm in the middle. Don't force cut. Take your time till you have it cut open. Don't force cut. Get my wax paper out here. And it didn't fit. I cut too much of the line out. So we'll have to, it's okay. I'm gonna just make a new one. Got more scrap here. Try that again. Excuse me. Make sure I don't leave make sure that I'm leaving the mark. Don't cut on the mark. Cut past it. Well, when you're close to the edge, you can always just sand it. That's better. The NCA. That's where it's stuck. I'm going to take the other piece. Since I've done the other one the same, sanded it off that edge. I'll round off the edge again. My CA gets very hard, so I've hardened the balsa here. Press down. I will have to use a tool to drill me a hole. Okay, there's the inside support for the rubber band. There's the other side, so when these go together. Okay, the next thing I will do is I want to put in the center parts of the model. I need to build a box, and then that way I can adjust from the box. And I also like to look at the plans to see see how much drag the model has on it, what type of flight this model is going to give me. So since the plans are available, we see that the propeller and where the propeller is going to go, and we want to look at that in relationship to all the bits. And you can see, I can see immediately that the elevator has a positive incidence in the built-in. So if I bring the elevator, if I put my line, a ruler, underneath my elevator, perfectly underneath the elevator, and then I look at the wing, in the very back of the wing, my measurements are wore out on my. I want my model to fly without it struggling so hard. So, and it's easy to see that I have a positive incidence in the model. So at the back of the model, I have a 1/2 inch. And the front of the model, the front of the wing, the leading edge, I have, I would say, close to 5/8. So it's like it is a lot of, there's a lot of positive wing incidents in this model. And what that does is that is good. I mean, that's good, but it's creating a drag. Everything is fighting against all of its surfaces are fighting against each other. So you got to think of your thrust line. A thrust line is the area in which it's being flown. It's an imaginary line. If you throw the model that way would be the thrust line. That direction is the thrust line. The area of travel is a thrust line. It's an imaginary line. So then you build off this imaginary line, if you will. So it's kind of, I want the model to go that way, which you can see where the propeller is going to be on the model. That is the direction of pull. That's the direction of travel, because the model is being directed that way. So if I was to draw a line, let's don't was to draw a line. Let's draw a line. What we're doing is we're studying the model to make it fly a lot more efficiently. It's going to fly. Yeah, these engineers design it to fly a good 150 feet. It's a flying model. It flies 150 feet. But if you're going to fly in any type of competition or any type of an event, you want more than 100 feet. So I'm going to take my pencil here, because a pencil can be erased or whatever. And I'm going to draw myself what I consider a thrust line. If my propeller is pulling my model down the runway or down the, if you look at this line that I've drawn on the model, see the little line I just draw through the middle of the propeller down. Now look at the elevator. Right here, the horizontal stabilizer is off the thrust line this much, giving a decalage of a pushing the nose down. It's a forcing that nose down, which is good because you have a flat bottom wing. I'm not maybe getting talking too loud. That it's a flat bottom wing. Flat bottom wing creates a lot of lift, but the model has to be flying faster than a glide to start getting in aerodynamical forces to start creating and generating the lift. So once you start flying faster than a glide, you're okay. But until you start flying faster than a glide, you're stalling. You're actually having to pull the model through an absolute stall. So the model is completely in a stall already from the get-go. So let's say, okay, never mind this thrust line. What we're doing is building in automatic down thrust without having so much down thrust, because that's probably what the engineers are saying. Doyle, we're just trying to make the down thrust easier. Since we don't want to put all the down thrust in the model, we're lifting up the elevator or the horizontal stabilizer to automatically give you a down thrust. Okay, let's look at that. So I'm going to draw a line under the wing down to the bottom of the elevator. So I'm going to keep a straight line. Excuse me. I'm going to keep the bottom of the wing perfectly straight line all the way to the back of the airplane to where they touch. Okay. Okay, this right here, if we went off the bottom of the wing, see my line I drew? And so if you look there, then it's showing that I have a negative incidence on the horizontal stabilizer, and I do have up. So it looks like I have some up there, see? So the thrust line is going that way. The wing is giving me a positive incidence, and then the elevator looks like it has a little bit of up if I'm looking at that. So how much of a degree do we have on the whole thing? So let's look at so I have my compass out here, and I'm going to go to the back of the model, and I'm putting this on 0 thrust line. Okay, so the thrust line up to the bottom of the wing is showing 1, 2, 3, 4, 5, 6, 7. That shows that it's putting the prop, the thrust line, at a 7 degrees down thrust from the bottom of the wing. Okay, that is a lot of down thrust. That is a lot of down thrust, but to me, that's too many things fighting against each other to make it fly efficiently. You want it to be flying smooth through the air. So what I want to do is I want to change some things. I'm going to change some things. I've done this, the first build we did, I got my 20 seconds. I'm planning on changing it again in this one because I want to fly my 20 seconds. So what I want to do is there's my thrust line. So I'm going to keep my thrust line the same, but I want to move it up a little bit to have a equal thrust line, but just at closer to where the elevator sits. So let's move it up I'm going to move it up the distance of one of these sticks here. Well, these are the leading edge. So I'm going to move it up this much, draw a line, and then I'm going to come to the back, and that's perfect. Okay, now I'm going to draw from front to back another thrust line, actually moving it up the same amount of distance on both sides. Okay. So if you ignore the bottom line, that's still a thrust line. It's an imaginary line, okay? So ignore the bottom one. Ignore the bottom one. Let's use the top one. That means that when we get back here to the back, where the horizontal stabilizer starts sitting, that means the back here needs to come up, because there's the line over here. See the top side, see the bottom side? So even if we bring this up to make ourselves have a 0 degree of travel with our elevator, so it is setting. So we gotta, if we can bring that to a 0 degree of travel, so I'm gonna take my fuselage now, make sure I have it to the inside. I'm gonna set it in the correct location in the model, and with it setting here in the aircraft, or on the plans, I'm holding in the right location. I'm looking at the thrust line. They're looking the upper thrust line, and it looks like I will need to remove a little bit at the front, and then add a little bit in the back. You can see automatically how it's built down in the back. See how it's got a downward. So this is, now you're saying I don't want to buy a kit and have to go through all this to make it fly. Okay, build it according to plans. It will fly. I'm just trying to explain to you the forces that are on the model to get a better flight performance. If you build according to the plans, just remember that the model is already built up with drag. It's already designed to have a down thrust built in. It's already designed to have the elevator is already tilted up to give yourself a push down on the nose. Everything is designed to work with each other to give yourself somewhat a flight. And then what you're going to need is you're going to need a proper motor, and you're going to need a proper propeller. It may be a 6 or maybe a 7-inch propeller to keep it going fast enough, long enough to get your 20 seconds. Because you're going to have to fly fast enough to get over, to make these things work. You have to get up to speed in order for the aerodynamic forces to work. So what I want to do is I'm wanting to turn this more into a glider. And then with it being set up as a glider, then I don't have to fly fast. All I'm having to do is fly. I can hand launch it and it's going to glide really smooth. So my goal is to change some of these areas on my model to where I'm more at a zero elevator with the thrust line. And I want to bring the leading edge down on the wing to where I'm at a little positive wing incidence, maybe 1 degree, maybe 2 at the most. Right now I'm at roughly 7 degree, because if I use my compass using the second line that I just add, I'm on 0, 0, and let me try to move the camera over top of this so you're seeing what I'm seeing. Okay, let me see if I can turn this around. What I'm trying to show you. Okay, right here is the thrust line right there. There is the middle of this compass. There's the middle of the 90 degrees. So there's the bottom line. There's the top line. And this is the wing. This is the bottom of the wing. So we're looking at 1, 2, 3, 4, 5, 6.5, somewhere around 6.5 when I brought it up off the bottom. So that this goes up to the bottom of this wing. But this here airfoil is going to give you lift anyway. You're going to get a lot of lift without having too much of this positive instance in it. Now all the windows and everything was going to fit better if you go according to the plans. And guys, that is what I'm trying to share with you to set your model up according to plans, if that's the easiest way you want to do it. This is a learning process. You can set it up exactly the way the plans said, and it should fly. It should fly. What I'm trying to share with you is an idea to make it fly a little better. So what I'm wanting to do is I'm going to lower the wing to try to get it close to 0, and then I'm going to lower the front of the horizontal stabilizer or the elevator I'm going to lower this down, back down to 0, so that the wing won't be doing, they've got something like this. And what I want to do is bring it down to this and to this, because the wing itself is going to give you lift. And I want the air to go under the wing, so I'm going to bring it up just a touch. And I want to bring this back to 0, because the thrust line it being pulled through, because I'm thinking the model will fly fast enough to have aerodynamic forces on it at the beginning of the flight. That's what gets it to go up. But as it gets low of power, the forces are not there, so you're gliding. So the glide will, if you got all this set up with a lot of drag, you're just dragging yourself into the ground. That's good. You don't lose your airplanes. You go out and fly them, and no thermal's going to pull them off as much because you got so much drag on the model. There's some pros and cons in this engineering masterpiece. It's an engineering masterpiece, and the designers of this know what they're doing. I'm not trying to belittle their intelligence at all. No, no, no. I think they're doing a fantastic job. Build it according to plans. Get yourself a good motor. You'll probably need a little bit bigger than a 1/8 of an inch, and you're probably going to need at least a 6-inch prop. You're probably not going to be used the kit prop of the 5-inch. Probably no way. It's probably too much or not enough, and it won't fly. And at my goal, I'm going to try to bring it down, get it back into glider mode, and then I'm going to try to use the 5-inch prop. I've made a long video this time. There's a lot of information in this video. Hope you find it interesting and fun to listen to. And my next step will be to make the box. I'm going to glue in the middle parts first, where I actually have kind of a box. Then I can bring in the tail and bring in the nose and make them start fitting together. All right, this is Doyle signing off. I'm going to finish up the fuselage off camera. Bye.